I'm an environmental scientist who studies the impacts of climate change on prairie wetlands and the organisms that depend upon them. And skip to the end, the news isn't great. These organisms, waterfowl, ducks, amphibians like frogs, their lives get disrupted by climate change. And it usually happens from having warmer temperatures, evaporating more water, more erratic rainfall, those kinds of things. We can study the impacts of climate change on a variety of organisms, but today I want to talk about the impacts of climate change on us, here in Danville. So to start, think back to some specific event, a weather event, that might have disrupted your life. Maybe it was the ice storms from 2009, the heat waves of 2012, the cold stretch last winter that froze your pipes, maybe a tornado, or the floods that we've had the last few years. Any of these events have disrupted your life in pretty significant ways. When we talk about climate change, all too often we talk about 2 or 4 degrees Celsius global warming. And the problem with that is that it's a global average over a lot of time, and it doesn't relate to the specific events that matter to our lives. Consider, for example, today is October 27th. We have 90 years of climate records for Danville, Kentucky. 90 October 27th that we know what the temperature was and whether it rained. The average temperature these last 90 years was about 64 degrees as a high and 43 as a low. Sounds pretty good. But the extremes were 85 and 24. Those extremes are really what matter, and the patterns of how those extremes occur are what really disrupt our lives. And that's just one random example, October 27th. If you look at the future of October 27th, climate scientists have come up with projections of what it might be like. For example, in the future, it is as likely to be over 90 degrees as it's been over 80 in the past. So in the future, maybe 10 degrees warmer, we will have a high 95 degrees, October 27th, right around Halloween. It's probably as likely, maybe it'll be above 80 1 out of every 3 years. So why does this matter? Well, if you're looking at the specific climate impacts of a disrupting weather event, you can look to the past and say, hey, there's a climate signature, this was problematic. Where does that occur in the future? How often might we expect some damaging event to happen? So I'll take you to the Chicago heat wave of 1995. There were 4 straight days where the temperature was above 98 degrees. Didn't cool down very much, had an urban heat island effect. Hundreds of people died. Hundreds of people died. You can look for extreme heat waves here in Danville in the climate record, and we've had 2 of them that stand out. One was 2012 that I mentioned, where we had 11 straight days above 95 degrees, and 6 of those days were above 100. Back in 1936, it was even worse. We had 18 straight days above 95. 11 of those were above 100. You can look at the future predicted climate, the projections that we have, and find some of those examples, like that signature of what looks like a twice per century heat wave. That's going to be common. In the next 10 years, it will start to be every single year. We will have a climate event like that. And by the second half of this century, we will have 45 days above 100, and temperatures will reach 117. It's a very different world that we're talking about. Same thing happens when you look at precipitation patterns. If you look at precipitation patterns, a really big, dangerous event often occurs in the winter. It could be a big rainstorm that causes flooding. We've had 2 of those in 2020, 2021 in Kentucky. It could also be an ice storm. I mentioned the 2009 ice storm. It could be a snowstorm or a blizzard. Those events often look like 5 inches of precipitation over the course of 3 days. It depends on what the temperature is, whether it falls as ice or snow or whatever. But those are really significant events that can disrupt our lives. Those are happening more often. As I mentioned, we've had 3 straight years with really significant flooding in Kentucky. Twice in February, once in July. So what can we do? If climate is disrupting our lives, how can we disrupt those climate impacts? How can we prevent them from damaging our lives as much as they have? And what can we do to change that trajectory, disrupt the warming so that we don't have those extreme events happening more and more often? Let's go back to Chicago. Fast forward 17 years to 2012. They have the same climate event. Rather than 4 days over 98, they have 5 in a row. But somehow, it should have been worse, but far fewer deaths. So what happened? In those 17 years, individuals, local governments, state governments, figured out we have to figure out how to respond to these climate impacts and mitigate those worst occurring events so that we don't have the death and loss of quality of life. We need to do that here. Secondly, we need to change what's possible in the future. We need to change and mitigate climate warming so that those extreme events don't happen as often, so that our lives are more like what they've been in the past, rather than this scary future that I've been telling you about. We need to do this not only because all of us experience these climate impacts, but because the most vulnerable, the young, the elderly, those who are housing insecure, experience these impacts worst and first. So I want to push you to find ways to change those climate impacts, to mitigate as much as possible so that we have to adapt to less extreme events. And I'll push you in one more direction. Where possible, try to find responses to climate change that do both, that both mitigate and adapt to climate change. I'll give you a few examples. One of them is planting trees. Sounds like a good thing to do. Trees mitigate climate change. They're pulling carbon dioxide out of our atmosphere, but they also disrupt those same heat impacts that I've talked about. They can decrease the heat island effect. They can cool our homes and keep us from having to run our air conditioners as much. And they can even slow down or attenuate floods. So one thing does both mitigation and adaptation. Another thing is geothermal energy. Using geothermal for heating and cooling can do the same thing, especially if you have a modest amount of microgrid solar keeping the pumps flowing. In a heat wave, it can cool down houses or buildings. When it's really cold out, it warms things up. So it's preventing those impacts from being as challenging to our lives. But it's also mitigating climate change because we're not using as many fossil fuels. We're not putting CO2 into the atmosphere when we use geothermal. So those are a couple examples. A third example, and I admit that I'm still developing and investigating this one. A third example might be direct solar-powered mini-splits. You've seen mini-splits. They're the heating and cooling things that don't have ducts and go directly into buildings. You can now run these. Just in the last year, they've developed these technologies that could go on people's homes and they run directly from solar panels without having to have an inverter or any other technology. Those three examples, among many others, are all things that can do both. They can both mitigate and adapt to climate impacts, so that we are disrupting the climate impacts that are trying to mess up our lives, and we're disrupting the trajectory of warming in the first place. I often tell my students that we aren't making a decision between no climate change and climate change. That ship has sailed. Instead, we're making a decision between how much we want to mitigate and how much we want to have to adapt to. And when you think about these examples of heat waves, 40 days in a row, 100 degrees, we don't want to live with that. We don't want to have the worst heat waves of the last 90 years become an every year occurrence. It's too damaging to our lives, to our quality of life, to our infrastructure that depends on, being able to transport things on our roads without them buckling under heat stress. Not having ice storms that take out power lines. The more that we mitigate, the less we have to adapt to. But we will have to respond to both. I'll leave you with this one last note. When you're trying to think about where you can have some action, definitely think about your individual contributions, your footprint, but don't stop there. Recognize everyone else is doing something too. We're all part of this. We're all sort of combining our efforts. And then start looking for your particular sphere of influence. So maybe it's your place of worship, your place of work, your school. Maybe it's your friends and family. Find that group, find that network and sphere of influence, and work on the policies and institutions that can help make us safer from these climate impacts. And let's disrupt climate before it disrupts us.